And over 20 billion device connections will exist by 2019. That's the good news, but the not so good news is that we're putting more stress on the network that, like most things, has limited bandwidth. So industry came up with a myriad of solutions to offload data traffic from the network. That's through next generation network technologies. But with 40% of the 23 billion connected devices expected to exist in the enterprise market, relying solely on our network will likely not work. And comes the widely adopted use of edge computing, enabling better business decisions using data generated by sensors at the edge. Joining us today in the Dell TI Now studio to discuss how enterprise and service providers can monetize this technology and business approach are Liam Quinn, he's Vice President and Dell Senior Fellow, and Bill Morelli, he's Director of IoT and Machine-to-Machine and Connectivity at IHS. And gentlemen, welcome to the program.
Thank you.
Now, of course, Bill, you might have already noticed that Connect What Matters is the moniker here in the Dell booth, connecting critical infrastructure, bridges, dams, transportation, traffic lights. Are we still talking about those smart city devices and areas, or have we moved on to more critical infrastructures, maybe like monitoring water or sewage?
I think we're starting to move to that conversation, but really the focus right now is on implementing systems that we can put in place quickly and at a reasonable cost. So for example, streetlights are one area where many cities are already looking at switching out incandescent bulbs for LED bulbs for the energy savings. So if you're already sending someone up the pole to replace the bulb, can we put in a smart bulb that may have a sensor package that can look at things like air quality, temperature, moisture, and potentially even microphones to help monitor security. Potentially those smart bulbs can also be access points for a municipal network. Then you can put related devices, things like trash bins on the same network. You can monitor when they're full, so you send the truck around to pick them up.
So I think that's a great example of IoT evolving and having that overlay network, a virtual network where you can extend that out to neighborhoods. And there's lots of other services you can overlay on top of that. So as you said, some security, manageability, environmental control and monitoring. So I think that's a great example of how IoT is going to evolve over the next number of years.
Now, of course, Liam, I mentioned edge computing in the introduction here, and some would say that edge computing is really the brains behind the Internet of Things. Others would say it's a temporary fix for the next 5 to 10 years until the core network can become robust and reliable, and we can rely on that centralized model. What do you think about that?
I think it's not an either or. I think it's a model that's going to continue to evolve, particularly with IoT, because networks can't sustain all of the new traffic that's going to be generated by actuators and sensors. So we have this model of edge computing, distributed computing, where you have control, data, monitoring and storage, and analytics out on the edge, where you can actually have local decisions, scalability and adaptability and flexibility of your network. So not all things have to go to the cloud, some will, and the cloud still exists, but it's a continuum, so you'll have layers of analytics, layers of control, layers of networking, all the way along the continuum, and it starts right out of the edge. And when you get sensors and the cost and the declining cost of sensors coming way down, that's where you get this pervasive deployment of smarts into the physical world.
Right, and what you end up with then is a tremendous amount of sensors that are deployed and collecting data. One of the main concepts behind IoT is pushing more intelligence out to the edge of the network. So those sensors are going to be increasingly smart, but the main focus at the node is going to be filtering out what's the critical data I need to pass on from what's the data that we can just discard, because it's business as usual in essence. So if you think about a security camera at the edge of the network, there's going to be an awful lot of frames where nothing's happening. And so do you really need to send that to the cloud to be analyzed? Probably not. You can put those on a lower priority and transmit them later, or just discard them completely. Then when you have something moving through the frame, that may be data that you want to pass up to the cloud or the next level. So then that could be handed to edge computing. That can determine, is that just a plastic bag blowing across the screen, or is that something I need to pay attention to because it's actually capturing maybe a mugging? And that would then go to the cloud to be analyzed, see if we can identify the attacker, notify the police, etc.
I think it brings up an interesting, and we're seeing it here at the show today, about different networking types. Some data is more priority, more critical than others. Mm-hmm. Some data like IoT is lower priority or smaller packet sizes. So it's an interesting dynamic that's happening today in both the licensed spectrum space and unlicensed spectrum space. The analogy I like to use is it's like a highway. So you have different lanes for different traffic types, different prioritization of traffic along those lanes, and I think we're in for a very interesting number of years ahead of us, both in the regulatory side as well as on the networking side.
The exciting part is we have more and more solutions available. So there's more tools in the toolbox, so to speak. So we're not just relying on Wi-Fi and cellular and maybe some low power like Bluetooth. Now you have low power wide area networks. You have narrowband IoT. You have things like 5G where they're actually looking at a more heterogeneous solution that's actually going to be incorporating carrier grade Wi-Fi.
Yeah.
And so each of those is suited to different types of IoT applications, and being able to integrate those is going to be incredibly powerful.
The interesting thing, and I mentioned earlier this concept of autonomy, is where some local devices, smart devices, can make decisions based on local analytics without having to go even further up on the network itself. And I also think the adaptability of devices to actually get on a network, whether it's a proprietary network, an open standards-based network, but it'll actually be able to navigate using multiple types of paths in there.
Well, if you think about, in a smart cities concept, if you think about critical communications and first responders, for example, you want to push that analytics and decision-making ability down to the lowest level possible, because you want the response time and the latency to be minimized to the greatest extent possible. If this is something where the authorities need to be notified, or maybe medical need to be notified, you want that to happen as quickly as possible. You don't want to have something sent to the cloud and go through a processing queue before somebody determines whether they need to call 911 or not.
Yeah.
Let's talk further about that, Bill, about maybe the network of networks. You have these commercial off-the-shelf sensors, thousands of them, millions of them, maybe billions of them, throughout various smart cities in different verticals, retail, agriculture, manufacturing. What's the interoperability concern right now and for the foreseeable future?
The challenge today is that many of these are talking in different communication protocols, and so it's being able to figure out how can we bring together the correct data that we need to do the analytics that we want to do utilizing big data techniques. And there needs to be some level of processing involved to allow that to happen, and interoperability is going to be a key issue. I mean, you just have a number of different devices from different manufacturers talking different languages in essence, and being able to abstract that out and get to a point where it's just pure data that can then be analyzed is going to be a key issue.
I think interoperability is at multiple levels. You have interoperability of the devices, you know, where you have brands today that we're all familiar with in the networking space. And I think that's something that needs to happen in the IoT domain, where you've got interoperability at the physical layer, at the networking layer, at the software layer, application layer. And that's something that we're actually driving into a number of consortiums that we're members of, is the need for interoperability in order to stimulate this market and allow connectivity and sharing of content and data across these devices and networks.
Yeah, it's absolutely something that we don't want to see become a barrier. And so I think there are a number of industry consortiums, associations working on different pieces of that, because that's one of the challenges. Like you said, it has to happen in a number of different layers. Yeah. So we may end up with interoperability at this layer and not this one, and that's something we need to work to resolve over the next few years.
Yeah.
Yeah.
Now, of course, we can't push all devices up into the cloud. As you guys talked about for the last several minutes, the edge computing factor in IoT is important. Where do the operators sit in this scheme, this new scheme, as far as monetization of their pipes? Is it advantageous for them in the edge and fog computing sector, or non-advantageous?
I think carriers like more traffic through their networks.
Sure.
I think there's their networks today are going to be constrained by the content that they have, voice and video and multimedia. I think that's where you're seeing some crossover of carriers into other domains, like we hear a lot today about the LTE actually operating in the unlicensed spectrum, and that's the reason for that is that it's free spectrum, it's unlicensed spectrum, and it's really offloading the network because they actually have to have quality control in the existing devices that they support. So I think there's going to this crossover between licensed and unlicensed. I think in a future world where it's 5G, you're going to have this concept of just pervasive connectivity, and people will actually have less of a concern between licensed and unlicensed. The carriers, of course, are going to start to push that down into more consumers, residentials, and IoT applications.
And even today, the carriers are looking to address different pieces of the IoT market, and they're continuing to evolve LTE. So LTE, of course, we all know is really great for high bandwidth applications. We need a really dynamic connection. We're also seeing that now start to have segments to address M2M and IoT specifically. LTE Cat 0, Cat 1, LTE M that are going to be standards that are coming out in the next couple of years are all designed for lower bandwidth, higher latency type applications. And so I think the carriers are very interested in utilizing the technology to continue to address these types of applications. And they're going to keep providing solutions that will do that.
One that we've seen is the concept of narrowband IoT, or narrowband LTE for IoT applications. And that's where they're slicing off some spectrum just for low data rates, IoT traffic over an LTE network. So it goes back to the earlier point, more traffic through the network is good for the carriers. There's more revenue opportunities there, and they're going to enable that in multiple ways.
So you would agree that maybe over the next 5-7 years that a more centralized model rather than a distributed edge model is something that carriers might find to be more conducive to their business plan?
I'd say to some extent, but you really have to think about how cellular networks are structured today versus 5 years ago and how they'll be structured 5 years from now. Carriers themselves are pushing more intelligence out to the base stations. What a base station can do today is vastly improved from what a base station could do 5 years ago. And that's just the nature of the technology. LTE is more complex to manage, 5G even more so. So in their own way, carriers are following this same paradigm where they're pushing more intelligence out to the edge of the network. So there's still going to be data going over the network, but it may be going base station to base station. It may not go back to the core.
I would agree with that. I think you have to continue to push it out. You can do backhaul based on the carrier networks, but again, they're pushing their technology into multiple areas in order to get part of the IoT growth opportunity.
I think a large part of our conversations here at Mobile World Congress has been about edge computing and fog computing, certainly an evolution there, and I'll certainly be talking about that further. So Bill, thanks for giving us your time. And Liam, it was nice to meet you. I've seen you off and on over the past few days, so it's nice to have you on the stage.
Yeah, appreciate it.
Thanks, Liam. Appreciate it. And for all of our continued coverage of Mobile World Congress 2016, you can go to tianow.org, and for social media, you can follow us on Twitter at TIA_now. So long.